Hello, everyone. Thanks for coming here today. My name is Mikko Mononen. I'm software developer at Unity. I previously worked on games like Killzone 3, working on the tools side of that. I was the AI lead on Crysis 1. And also, I'm author of Recast and Detour, if someone knows that.
My name is Jakob Hunsballe. I've been working at Unity for 3 years. I've been in the industry for 8 years, previously working on Hitman Absolution before coming to Unity.
So today we're going to talk about, I'm going to give like a quick overview of the NamUs stuff. We're going to do like a demo of the workflow, how you can build stuff with the NamUs stuff. We're going to have a big, small update on the things we did for 5.0. For us, it was like a big refactor. There are not like tons of new features, but it's more robust and faster. And finally, I'm going to talk a little bit about the feedback we have gotten from users. So in a way, it is like our kind of filtered version of the stuff we are hearing from you guys. And in a way, it's going to be the stuff that's going to affect our future roadmap going forward. So let's get started with the NamUs overview. How many of you are actually working on AI in games? OK, so it's about 50-50. So anyways, navigation in games are usually represented as a NamUs. So the NamUs is like the walkable area where the characters can walk. In Unity, we built this NamUs automatically from the level geometry. So just to like select objects and press bake, and that's pretty much all you need to do. From this NamUs, we can figure out a path, for example. So it's like a mesh of connected polygons. And each of these polygons represents like convex area, where in a convex area, we know that we can get from any point to any point. So there doesn't need to be any pathfinding. But since you have pretty complicated levels, we need to somehow figure out how to get away from one room to the other and stuff like that. So the NamUs can handle that. And the first thing that you do when you tell the character to go to a different place is that you find a path. And that will basically return you like a linear list of polygons to follow to get to your target. And we call this linear list a corridor. And it basically tells you the rough path from the beginning till the end. Then on each frame, as we simulate the characters in the game, we do steering. And since we have the linear list of things to go through till the end of to our destination, we always just like every single frame, we're going to find the next corner to steer towards, and that will basically lead eventually us to the goal. And we do this every single frame so that we can freely move the character. It doesn't have to stay on like a straight path. It can deviate from the path because maybe there's multiple characters you need to do avoidance and stuff like that. So this allows us to like really robustly move the character till the end of the path, even if some like small errors kind of add up during the simulation. And finally, there's obstacle avoidance. So in that phase, we try to do predictive avoidance of other characters or maybe other obstacles in the scene. And the reason this isn't like clustered in the pathfinding is that the NamUs, it represents like the static snapshot of the level. But if you have multiple things moving in the level, it's too costly to update the navigation representation each frame. So we have this like a collision resolution or actual predictive collision avoidance, which is like a last bit before we feed all the stuff into the animation system. And the dotted line here roughly shows like like the first 3 things we handle in the NamUs system, and the last thing basically is going to be in Mechanim. And currently there isn't like a direct connection between the two, so you need to kind of bridge that using scripting if you're using the NamUs things. And the tools you have in Unity to build this kind of navigation for a game is basically the NamUs, and you basically create the NamUs using a bake process. Jakob will later kind of show you the workflow, how this happens. Then we have a bunch of components which basically allow you to build the rest of the things. But the most important one maybe is the NamUs agent. So if you have a game object which is your character, you just plug into this NamUs agent component, and then in this component you can basically set the destination, and the NamUs system will figure out the path to the goal, and basically how to traverse it. It will at every single tick you will get more information on how to simulate the character towards the target. But sometimes you need to have these dynamic obstacles in a level. It could be the usual like crates and barrels in shooter games, for example. The obstacles, they can be, when they are moving, the agent tries to kind of predictably avoid them. But as they get stationary, kind of like the simulation settles up, you can also kind of infer this information in the global pathfinding. It could be that a couple of crates are basically blocking your way. You need to basically make a big detour in order to get to your destination. So this thing is handled also using the NamUs obstacle. And the way the NamUs obstacle works is almost like a physics collider in a way, that you just like plug it in. It's a component you put on your basically a crate or a barrel, and then it will basically affect the agent navigation in a number of different ways. And finally, there's off-mesh link, which allows you to do things like if you want to have a door which has a logic, like it can be open or closed, there could be a special animation you want to apply there to get through the door. The off-mesh link is basically taking care of all that thing. You can turn it on and off, and you can basically detect when the character is close to the door, and then play the special animation to go. Or it can be used to like traverse across things which are not kind of usually walkable, but you need to make jumping across things or jumping down for roofs or whatever you find useful in your game. So now Jakob's going to show you basically the workflow, how to create the NamMesh and agents and obstacles and so forth.
Yeah, so I have a video recording here of the basic workflow. We are basically going to try to reproduce the drawing that Mikko showed just before. And first things first, we need to bake the NavMesh first. And for that, you see I've created the blocks here. They are just static blocks, 3 cubes. Open the navigation window. And we see 3 tabs. We have an object tab, a bake tab. We'll go further in depth with that later on. This represents the character that's supposed to walk on this surface. We have an area tab. And the area tab here. Wait a minute. I think we skipped the video here. All right. We select the 3 cubes. Open the navigation window so we can bake the NavMesh for this setup. Go back, see this once again. Sorry about that. So we need to annotate the static geometry in this case, and so we go to the object, select the 3 cubes, and we have the static flag. You can set the static flag in a normal way you're probably used to, or you can go in here and just select the navigation static. We pick walkable, which is the default, and you see the blue mesh appearing on top of the geometry, and that's now the walkable mesh. We also have support for different types if you need that, like create a grass here and bake again, and you see that's the green colored thing there. Now let's just go back and have walkable standard, the default walkable area type, and you can see the areas here where you can configure things. If you have 28 or something like that for your for whatever you need, and there's 2 built-in types, and then there's like a void, not walkable thing. If you need to make a specific, like a block out a hole or something like that. So that was the baking, and now we will go through the 3 components. First, we will take the NavMesh agent, as Mikko showed, and I think we're rolling. So first things, we'll create a cylinder just to represent the agent, and it's done here. Place it firmly on the ground, and we go back to the inspector. And it's really nice to have, if you want working with NavMesh, to have the navigation window open at the same time, because otherwise you won't get the debug graphics. So that's why I just dragged down here. So we have both the inspector visible and the navigation window. Now at the NavMesh agent component, there's a couple of properties on it, the speed and so forth. There's obstacle avoidance. You can disable, enable it, change different quality levels, prioritize the avoidance and things like that. We'll go back to that, I guess. So now I just add a little script to to get some action going. It's a click to move script. I'll show that a bit later. That makes it possible for us to just click somewhere in the level, and using a physics raycast from the camera, we'll get a destination in the geometry. Now you can I'm just switching on the gizmos here for the play mode, so you can see the nav mesh, and there's a bunch of debug graphics here. You can see the path, the destination, and different things. If we have avoidance, you can see the obstacles, and you can also see the dark polygons here, the query node. So that's basically showing where the path request is going through the polygons. You can also disable and enable the nav mesh, obviously. So this was the agent. Let's move on to the obstacle. And so just stop here, and now I'll add a box for the agent to avoid. So I'm just creating a cube in this case, and just blow it up a bit. Red means no, so just put a red material on it. So we have a box collider, that's the standard. I'm just going to keep it there. It's not really needed in this case, but just for reference, so I'm just going to keep it there. And you can see the obstacle in this is 5.0, and it's changed a bit. Now we have a box and a capsule shape, and you have the center and size properties as you do on a box collider. So you can think of it as kind of a collider in the navigation system, but it's not physics, right? So now the agent will sort of bounce on this thing and eventually find its way around it. And there's no physics involved in this. Now, this is probably okay if things are moving around, but in the case that things get stationary, you want to pathfind around it instead of just bouncing off or sliding off things. So there's a carving option on the obstacle, and you can see the white wireframe around the box here is telling you what kind of shape is carved around. You see there's a bit of a expanded box here. It represents the radius of the agent, so we can approximate the agent movement with a single point. That's mostly for efficiency, but so you see the same sort of cutout size as you see around in the level. Now you can choose to switch to like have a carving done every frame, and you can do that in play mode. And but in the general case, you want something like this where you can move the thing around, and when it settles, there's a timeout, and it gets stationary. It'll carve out, or you could carve every frame if you like. So I think that was the obstacle. Now, final component I'm going to demonstrate here is the off-mesh link. There you go. No. Okay. So we need a couple of game objects to represent the endpoints of this link. I'll just create two spheres. I mean, I could have created empty game objects or something else, but in this case, it's just easier to manipulate. So just add a couple of spheres, shrink them a bit, and and now we add the off-mesh link component to one of the spheres. Usually, just pick one of them, or you could have it sitting on any other game object. If you want to cluster logic on a bunch of off-mesh links on some logic, you could have like 10 off-mesh link components sitting on one game object, and you could disable the whole thing by disabling the game object. So that's also a use of it. These links can be bidirectional or just one way. In this case, we choose bidirectional, and you can switch on the auto update position. That means that you can move the endpoints in the game and it will update. Otherwise, you just tick that off or disable the auto update, and it'll just be stationary there. So now we can move across, and that's basically the baking and the 3 components demonstrated here. Now, I showed a script, or I didn't show a script, but I placed the script and I click to move, I think it was called. That's using the API that we have, and basically this is the script. It looks way more complicated than it is really. You see a yellow arrow there. That's basically the NavMesh API. What's going on here is that the user clicks a button, and we do a raycast, and then if we hit something, we just assign the destination to this point. We also have a red sphere being drawn here. So I mean, yeah, it's just an example, right? So.
Okay, continuing from there. Some of this stuff was maybe, if you have used Unity, you kind of know it already. So we're going to go through a bit like the updates we did for 5.0. So as I said earlier, like for us, 5.0 was a big refactor. So basically, we took a look at the whole system, and we basically took away a bunch of like really odd limitations that it isn't too easy for the user to understand. For example, they were kind of arbitrary limitations on how big worlds you can have, or there were some off-mesh links cannot span like a long distance and stuff like that, or the path link has a certain upper limit. So all these are now being removed. Also, we spent some time on rethinking the obstacles and trying to make them to behave like physics counterparts. So it's easier to basically add more functionality to your existing things. Also, we had the box and the cylinder shape. Previously, it was just axis-aligned cylinder, so you were really limited on what you could represent using that. And the box shape is a really kind of useful, simple thing, especially when you're using carving. It's kind of the fastest primitive you can use. And the one kind of like the big motivation for us to do the refactoring was load level additive. Previously, we didn't support basically load level editing is a feature which allows you to do a kind of load a second scene on top of existing ones. A bunch of people are using that for all kind of purposes, but we didn't unfortunately support the NamUs for that. So now you can have multiple kind of NamMeshes loaded using this load level additive. And it kind of required us to do some refactoring under the hoods. So here is just an example of the obstacle we saw at the workflow earlier. So basically, what we've done there is that we take the box shape, and then we try to, depending on the rotation and whatnot, we try to simplify the shape which you're using for carving, just to give like the maximum performance. Then we want to have more performance. Like if you make a bigger words, you want to have less memory being used. So in certain cases, especially if you didn't use carving before, now we have like a 50% savings on the memory being used. In many cases, yeah, I think that's roughly like we were duplicating some data and so forth. So it's better now. There's a big like effort throughout the company to make everything multi-threaded, and we kind of chipped in by making the carving and the agent updates multi-threaded. So I can show you like a quick here. So here we are simulating 1,000 agents. They're all kind of avoiding each other and navigating in one scene. It takes 1.7 milliseconds, and what you can see there, like in the first thing, is the main thread. And it shows like the whole time it takes for this update of all the crowd agents. And then there's like multiple things. Like the first thing is basically doing proximity queries, like finding agents around you, and it's being handled all in all the four threads that we're using there. The same for obstacle avoidance, and then finally same for basically integrating or handling the final results, moving the characters. There are a couple of like things that we want to eventually kind of, there's a little slack there, so we hope that we'll continue this effort and then try to make it all kind of one nice package eventually. And finally, we think that there's a lot of new users coming to Unity. There are a lot of ways we can actually help users by giving them a bit more hints how the systems work. So we spent some time to make better debug throw, so you basically can see what happens under the hood. Now it's kind of like, it's still a bit like a black box how the whole system works, but we want to make it more of those things kind of visible to the user. Like here, we just like the quick screenshot of the debug row on the right. And this is also going to be something that if you're making bug reports, these things are going to help us a lot. So we can also see that if there's something wrong, we make mistakes occasionally as programmers. So there might be something that we didn't take into account when building a system. So the debug row always helps a lot to be able to see kind of the context, how things are working, and what kind of things are happening there. And also we try to make we're building on to make a better documentation. Also, we try to bring some of the documentation directly into the UI as well. Like on the left is the new bake settings window, and it tries to basically tell you like what's the correlation between different settings, the agent radius and heights and step heights and what all those things mean. So as you have this interactive diagram, it's a bit easier to grasp like how different things are affecting each other. So Jakob is going to do a quick demo on how the load level additive, how the workflow is, and how this works in practice.
Yeah, so I'm just going to demonstrate with a little setup here. We have a cylinder in the middle, which is an agent, the same kind of agent I showed before. And we have a floor here. I'm just going to kick this off. And so we want to have two scenes. We want to load the second scene additively. So as you go into a new room, say, you load the NamUs for that part. So yeah, here you just see it's the same kind of agent. We have like a ground or floor here. And I'm just going to mark it as navigation static and bake the thing. I'm going to load up the second scene, which just has a ground on the opposite side. The thing to note here is that I don't have a light, I don't have a camera in here because I'm going to load this additively, so I don't want to add another light or another camera. So back to the first scene. We need to connect these things. We cannot rely on geometry being completely matching on either side. We can't know what scene somebody's going to load at what point. So the way to connect additively loaded scenes is to set up off-mesh links. So I'm just going to go through the exercise of setting up an off-mesh link once more. Now the good thing about this is that you can see where it's going, and when we load additively, even though this just points into a void for the time being, when the second scene is loaded, the anchor point that's now in the void will be connected to the other side, and you have a way to cross. And you can see now, left side is connected. There's a ring around, and the right side is not connected. And you don't see a ring, and the whole thing is alphaed out a little bit. Now I'm gonna add a button. It's really simple. It has a scene name, the scene we want to load. That's it. We have a button, some text on it. We call the application load level additive with the scene name, and then we just destroy that button. We don't want to load the same thing twice because, yeah. So we need the scene name. But actually, before doing that, when you want to do the load level additive, you have to add your scenes to the build settings. So I'm just going to add the first and the second scene here. Otherwise, we can't load. And I'm just going to type in the second additive here in the scene name. And we should be good to go now. You can move around and you load, and you can cross to the other side. Now, this load level, I don't know how many went to the roadmap session, but we have a new API coming up that's called load scene additive, I think, and unload scene additive. And with that, this will be even more valuable, of course, because now you can, with the unload scene additive, you can unload the previous session and you can have some streaming action going on. But that will be not 5.0, but 5x.
Okay, and then the final bit, which is the feedback from the users. So we're going to have a Q&A after this, so we can get even more feedback. So during the spring and winter, we've been talking to a bunch of people on what they would like to see on the NamMesh, what kind of new features, or we've been trying to understand their workflows, or we are understanding what kind of games they're working on. So this pseudo diagram shows kind of like the different kind of users we identified, which we could potentially use NamMesh or are currently using NamMesh. On sort of like axis going from bottom to up, there's the complexity of the AI these guys require for the project. And going from left to right is basically how much scripting or programming they are willing to put into to get things done. The two kind of grayed out people on the left, we are kind of leaving those people out for now and concentrating on the people who can do at least like entry-level scripting. So, for example, the girl on the lower left, Mia, she would be, for example, an architect who wants to just like spice up her architectural visualization using a couple of characters moving there. Unfortunately, we currently can't make it so simple that she would be able to use our tool yet. But I think it's something that we keep her there just to remind us that eventually we want to get there. Also, Lauren, he might be a game designer, having cool idea how to make the next coolest multiplayer single-player FPS game or something like that. So his requirements for the AI is really high, but actually he might not be able to do any scripting at all. So the kind of the gamut of users we are currently aiming for is like from Fernandez through Ivo to Oleg. And Fernandez might be this person who's just getting into Unity. Maybe he knows enough programming to be dangerous, but he might have such a high requirements for his AI. So we want to cater him in one way or the other. It might be basically helping out him, making the things easy to use. While Ivo is this guy who has been programming forever, but he's new to AI. So basically his requirements and is basically tight because he doesn't know AI. So we want to help him to get up to speed, understand how things work, and how to make the game efficiently. Eventually he will maybe get to the Oleg thing, depending on the what kind of games he will be working in the future. And Oleg might be this guy who has worked on AI for a long time. Now he wants to kind of make the next game to be totally multi-platform. He wants to use Unity for that. So this is kind of the gamut of people we try to cater. And starting from the feedback, basically, the first thing that we see people asking us is basically how to store, how to basically have better tools for building the navigation data. That's kind of like the base level component where all the navigation stuff is being built on. There are things like how to store multiple NamMeshes per scene. Currently, there's only one. When you press the bake button, that's the only thing there is. But maybe there are cases where you want to kind of have multiple character sizes, like in this picture. Like this might be the most requested question. The solution there is have multiple NamMeshes for different character sizes, and that's something we really would like to support. Or it could be that you have this level which is spanning along like a long distance, but you only have like AI action on single kind of places in the level. So maybe there's a reason to actually have more like a localized thing that you can say that I want the NamMesh only be over here, and things like that. It could be that this kind of bridges the third thing is how to store NamMesh in the prefab. So there are multiple people coming to us and saying that they're making these like a procedural dungeon games, for example. It would be really cool to, if you are, I can see someone like cheering over there. Okay, so it would be really cool to be able to store the NamMesh data in the prefab, which is like one thing you instantiate in your level, which kind of calls for things like you should be able to rotate the NamMesh and stuff like that. So that's something that we're looking into how we could solve this case. But it's kind of like, I see it as like a sub-case of the first one. Like if we are able to store multiple NamMeshes per scene, I think we can handle the prefab thing as well. There's a way to store the data in the prefabs. How to handle user-generated content. I think that's kind of like a different scenario of the prefab thing, that maybe you allow your users to build the whole level, and it would be nice to press the bake button, but it doesn't exist at runtime. So maybe there's something we could do there as well. There are certain limitations there, like memory and stuff like that, but this is something definitely we are investigating to try to find solution. Then on the other side of the pipeline is basically how do you feed data into the build process. So the build process, like the simplest input is a triangle which has an area type. And then basically the whole scene is multiple triangles with different area types. So that's already like the whole kind of the code for building the NamMesh is flexible. But I think we need to find a way to make the API more flexible to be able to submit your own meshes, maybe using the physics mesh. Like if you already have like a tree, it might be that you're just using capsule for the collision. So we should be able to kind of allow you to do this distinction, like what kind of data you're passing to the NamUs builder. Also, annotating areas. There's only so far you can go with just saying that this object is a certain material. But maybe there's other ways, like for example, describing some volumes. It could basically paint stuff inside it and stuff like that. So I think there's many ways to handle this thing, but it's something that is being asked for. The second kind of range of things that we've been approached and we kind of learned from our users is that the API we currently provide for handling things in NamMesh, and especially with the agents, it's almost like a black box. It's almost like a physics system where you put stuff in and you get the vector back. And in many cases, the moment you start moving your character in the game, you're creating gameplay. Like every kind of small things that happen there, they all they all kind of eventually kind of create the kind of style and feel of your game. So what we kind of the feedback we've been getting is that would it be possible to somehow chop it down the whole API into different chunks? Like we provide a way to do pathfinding in the NamMesh API itself, but there's no way of sort of like building your own character on top of that. Or maybe it is, but I think that we could make it more flexible. There are some goodies we haven't exposed that we actually have internally as well. There's also, like in many talks, you may have heard about these low-level and high-level APIs. And this is sort of like if you remember the guys in the earlier slide, like the Oleg dude who is like really kick-ass, he might want to use like the lowest level API and build a kind of AI LODs and whatnot on top of that. While some other guys might actually just want to use like the default characters to move some characters in the default implementation to move the characters in the scene. And we're now seeing like really interesting thing in the GUI thing that they actually built like low-level things, and they're building then the whole API package on top of that. So maybe there's something there we could we want to experiment and see that what would be the best way to approach there. And yeah, and then there's like, if anyone knows the game Republic from Camouflage, yeah. So there was a talk earlier this year in Vienna in Game AI conference, and they talk about how they built their the navigation within Unity. So the really cool thing, I was really awestruck when I saw that, was they actually used the NavMesh sort of as a walkability test, but they kind of built their own kind of a waypoint graph on top of that. And I've seen that in many games, like at the Guerrilla, they had this like a waypoint graph, which is being used for tactical pathfinding. Like there are many cases where NamMesh isn't the best representation of data. So I think this is something that we could also help you guys to build better tools for creating more tactical things or whatever you want there to be. Or there was another game we're just using sort of like building like a waypoint graph, really rough one, which is basically describing the flow of the game. And they were building like, these guys were building it's a Space Ninja game, I forgot the name. Anyways, I think that there's for AI, I think the worst thing you can do is always use the same data for everything. And I think the NamUs is to agree like the best way to represent the data for walkability. But then what comes after that, I think we should be more flexible on handling things like that. And finally, annotations like putting tags on the ground, like whatever cover points and health packs and whatnot. So I think all those things should be more. There should be more kind of granular API to have more access to the NamMesh, so you can make better queries and stuff like that. And finally, I think this is sort of like the big goal we are trying to kind of head towards is how to bridge the AI and animation. We have really kick-ass animation system mechanism in Unity, and we are really cool NamMesh system locomotion stuff on the other side, but kind of bridging them two is still a bit flaky. So what we want to find is basically ways to build your assets so that you can have the kind of locomotion and the kind of dynamic model that the AI can handle with. This is going to be like a long stretch goal for us. Or maybe handle things like when you have locomotion and then you have these like action animations. I think the usual games are built so that you have a bunch of characters moving and then they're doing stuff and then moving and doing stuff. So this doing stuff is kind of like we call them actions. And I think there's ways we could help you guys to basically bridge the gap between those two things as well. Like the off-mesh link is basically the basic building block currently for creating actions within locomotion. But I think we could go even further and maybe even this mechanism is based on kind of, it's quite easy to share animations in the mechanism world. So I think there would be maybe a chance for reusable kind of actions, which can be also plugged into some AI stuff. So I think like this is the thing that we are really amped up on eventually solving. But we have like all these things to do before we actually get there. So in summary, 5.0 for us it was big rewrites, refactor. We built, kind of fixed a lot of bugs. We removed a lot of restrictions. There's performance fixes, multi-threading. I think we're really excited to give that to you guys. And we're still looking for feedback. We have gotten a lot of feedback from just talking one-to-one to users, looking at the forums and whatnot. And the main things we are getting from you guys is that you want more kind of flexible build process. You want to have maybe more control over things, more granular API, not just like black box where things are being simulated, but actually being able to creatively misuse everything and stuff like that. And then finally for us, something we kind of try to kind of look further ahead is the bridging the AI and animation and making sure that the two systems like work perfectly together. So now it's time for questions. You can also visit us as a hands-on lab. So after this session and tomorrow, we're going to be downstairs, or is it upstairs? Anyways, hands-on labs. And we would still like to get lots and lots of more feedback on this. So if you're working on a game where you chose not to use the NamUs or you're using it, please let us know. Let's have a Skype or something like that so we can kind of get to each other much more. There's also our email addresses. Feel free to send us roses and rocks, or how the saying goes in English. Yeah, thank you.
Questions?
Do you have plans for nav meshes to go up vertical surfaces for climbing AI?
So the question was, is there plans for vertical nav meshes? We're thinking that if you're able to rotate the nav mesh like this, why not like that? So I think that should able to, like, the nav is always going to be projection from one direction, but we're thinking that we can make them sort of like connect to each other somehow. So it's really like wishy-washy reply, but what we're trying to do is to see if we can basically have the nav mesh at any orientation, but it will always be like a projection from one. That's sort of like how the nav meshes are being built. There's something that we didn't mention, but like currently the off-mesh link is just a point-to-point. There's one thing we've been looking into, not yet solved yet, maybe having like a segment-to-segment off-mesh links, and that would allow some of the use cases where actually you want to have like more like, kind of climbing or bigger surface. Yeah.
Path finding's like a small part of AI. Like, what other kind of AI stuff are you guys looking into? You know, like, say a character gets shot and he's hide behind a corner or something like that.
Yeah. So we're currently concentrated only on the NamMesh stuff. We are a team of 2, limited resources. So we try to kind of focus on things and make them really, really, really good. There are a couple of packages in Asset Store. Like, I think Emil is giving his talk maybe.
I don't know when Emil has his talk, but.
Okay, so basically he's been working on behavior tree, which is basically handling the behaviors for characters. So you should check it out, and it's a really nice package. Over there.
So you talked about like the procedural dungeon example.
Yeah.
You seem to imply that the way that you would link those nav meshes is with an off-mesh link. Have you looked into at all doing nav mesh merging in that case? So it's a more natural connection?
Yeah. The problem with we've been looking into nav mesh merging, or at least being able to mark like almost like a portals which will automatically connect. So that's sort of the direction we want to go. That it's more automatic, but it might still require some authoring because we don't know what's going to be on the other side. So like if we can say that here's the doorway to something, and then we can merge them together. But that's probably the solution. Yeah.
So when you're saying that you can only have one nav mesh per scene, but then when you do a low-level additive, you're adding another nav mesh in.
Yeah.
How is that different than having multiple nav meshes?
On the back end, it isn't really. On the back end, we're ready for this, but as it is right now, scene and nav mesh is one-to-one. So what we do when we do load level additive is we extract the nav mesh from the other scene, and then just add it on the back end to the current scene that's loaded. So on the back end, we're kind of ready for that. I think with the unloading, things become way more sexy because then you can do the.
We were looking how other people solve this problem, and some are, for example, using like there's quite a few ports of recast into Unity, and some of them are, for example, using a component on a game object, and the component is describing an area. And then that way, because you have multiple components, you can have multiple NAM meshes. So that's like one potential road to take. But we're still looking. Like currently, there's like just like with light maps, the NAM mesh has sort of like there's a pointer in the scene data to the NAM mesh asset, and that's a restriction we want to kind of remove eventually. But that's still in 5.0.
So one of the things you showed in the presentation was different type of ground types. For instance, you showed like a ground type of grass.
Mm-hmm.
Yeah.
How can we use that? Is there a way we can access that information within during runtime? So that we can,
You can sample it. You can sample along the path in front of you. Say, give me the type 2 meters ahead or yards or whatever your unit. You can sample directly under. You don't need a path to sample it. You can also just sample a point. You can use those things as a mask on the agent, so you can sort of ban certain area types, so the agent won't go through that, and you can change that at runtime as well.
Is there a command to sample that?
There's an API call for it, yeah.
There's a few methods in Detour that are not available in Unity at the moment. Things like finding a random point on an mesh near an agent. Are those going to show up anytime soon?
I think the best way is just like contact us and let us know. The version of Detour in Unity is pretty different, like because all the multi-threading and all those things, it has evolved over the years. The recast is pretty close, but the Detour has changed quite a bit, mostly due to the kind of slightly different requirements in certain places, and the biggest thing is really like how we handle the data. So we have removed some restrictions that are in Detour. And also the multi-threading it's a big thing, how it changes everything. Yeah. Let's take one from the back.
So you talked about user-generated content, and you implied that needed to be tied to prefabs that still have baked NAV meshes. What about content like world geometry that's completely procedural?
Yeah.
Do you have plans to support that?
So I think runtime baking is feasible for some type of games. Like if you have really complicated geometry, it can get really slow, or it can require too much memory. But that's something that in a way, there's no reason why there wouldn't be a bake button at runtime. We just need to expose that API and so forth, and see that we can. Like currently in the editor, we care about memory usage. But since the desktop, you don't have so big restrictions as in iOS, for example. So we need to find a way that how you guys can also kind of tell us how much memory it can use and stuff like that. So that's like the big chunk of work there, and also providing as we get the input API better, like it's easier to kind of shovel in the level geometry, and then I think it's possible to handle the baking at runtime. But that's sort of like my dream as well, to be able to just like you load level, whatever happens, and then just make it calculate. And there are different use cases for that as well. So maybe in some games you want to kind of pre-bake everything, but as something changes in the level, you just kind of change the NAM mesh on that particle spot in the level. So there, like I think we are in like 4 or 3 different cases where it could be used. But that's something we are really interested on solving. Yeah. So the one way back. With dynamic NAM mesh, do you mean that?
If you have, let's say we generate meshes every
Okay.
mesh changes.
Yeah.
Do you support meshes for those?
So what we have, there's something called NAM mesh obstacle, and it can create the holes in the NAM mesh. So that's something we currently support in. I think it's already in 4.5, and in 5.0 we have a bit more functionality for that.
So that changes with the mesh changing dynamically over update.
Yeah, but for that we need to be able to bake at runtime,
Yeah.
and that's.
Blow up a wall, can you go through it?
No, But in
Unless
theory,
you add an off-mesh link.
you can fake that in a couple of ways. You can have an off-mesh link there, which can spawn at runtime. Or you can do that, you bake the NamMesh with the wall having the hole already, and then have the NamMesh obstacle with carving on top of that, and just disable it at runtime. So there's like, in many ways, if you think upside down, there might be a solution. And yeah.
Does the NavMesh area have to be continuous? Can you have like squares on different ends of your map and have that be one NavMesh?
So yeah, what we say that there's one NavMesh per scene, it's basically, it can have multiple islands. That's what it's usually called, like different islands. It can, yeah, usually the process even generates things inside big objects and on the rooftops as well. But yeah, you can have multiple things. It doesn't have to be all connected. Although there has been a request to make it the other way around, that you can place a beacon and say that I want to only have the NavMesh which is connected to this particular point. That's somewhere on our nodes, yeah.
Can you have different levels with NavMesh being, basically, is it one position per, in the plane of NavMesh? Or can you have, like multiple floors?
Yeah. It's like a 2.5D in a way. Like in many ways, the NamMesh is kind of like the walkability, like how you can slide along the surfaces. But you can have multiple stories and can kind of curl on it like bridges and whatnot. Yeah.
And if you look at the bake settings, you see the height in there. That's the free height you need. So if you have floors that are too close, then yeah, I mean you would have to adjust the height of the bake settings.
Over there.
You talked about having multiple NavMeshes per scene, and if you were to do that, is it on the horizon to assign NavMesh agents to only respect one particular NavMesh?
Yeah, that would be ideal.
Yeah.
Flying enemies on this NavMesh.
Yeah. So one thing that we don't like too much currently is that there's the agent settings agent has a radius and height. Also in the NamUs build process you need to give them, and there's no kind of tight connection between those two. So maybe one option would be that we had like a way to define an agent type, and that could be used both in the NamUs agent as well as in the build settings. And that way you could kind of use that also as a binding. So if you have multiple NamMeshes for different character sizes, they're going to be on top of each other. So that could be one way to sort of like differentiate that which character is going to go to which NamMesh. So short essence, yes. Over there.
Do you have any interest in making a volumetric pathfinder as well? Like I know the way that you generate the 2.5D thing is by first doing volumetric computations.
Yeah.
You can make a pathfinder for flying units that operates directly on that data. Do you guys have any plans for that?
If enough people want it.
Yeah, I think that's also something that we don't have it sort of. It didn't come up in. I think there was maybe 1 or 2 guys who mentioned that when we did basically did talks with users. So there hasn't been that many. It's usually really specific games which want to have that. But if there's enough demand for that, I think that's something we could look into. Or maybe there's a way we could sort of provide some APIs so it would be easier for you to build your own. But currently it's not sort of. It didn't kind of fail below the line. There wasn't too many people required.
To be honest, I don't have a current use for that either. I was just curious because I've used it in previous games.
Yeah. Right.
Can you talk about multiple agents on screen and prioritization in terms of who wins?
Yeah.
If you have 100, then
yeah.
you have crowding.
So currently all of them are being updated equally, but we have some demos we have done ourselves, which basically takes the frustum and the sort of the proximity to the character into account to kind of decide in which order we ask for path. Because like if you have 1,000 characters, it's going to take a while for all the paths to be calculated, and we only update so many kind of paths in one frame. So you currently need to do that yourself, and it seems like there's no like one-size-fits-all kind of solution for that as well. I've seen many games like Assassin's Creed, what they do, that they actually even throw away some characters which are not on the screen and stuff like that. So they're really kind of like harsh LOD. They only kind of show the stuff that's on screen. And in that case, you also need to do things like fast forward into the behaviors. So it becomes like the whole locomotion and the behavior comes really intertwined. But maybe that's something that as we expand more of the API, it will become easier to implement that sort of things. But they usually, simple things are easy to do, like just updating them less regularly when they are far away. But then then having more complicated things, it becomes really, really specific to your simulation or game pretty quickly.
Is there anything we can do to control it, like if there's a choke point? So you could say this type of character has priority?
Oh, you mean like the avoidance thing? Yeah, so there's a yeah, it's gonna be easier this way. Player, okay. Play. Show it off.
Okay, so here we have like a player character that's moving around, and it has a priority over all the colored, different colored cylinders you see moving around here.
So in the agent,
so it will just push them through. So there's like you can maybe I can
somewhere in the agent settings, yeah.
There's an API for that, but I think it's even exposed here. Yeah, the priority. That's one.
Oh yeah.
Yep. So if two agents have equal priority, there will be 50-50 avoiding each other. If one has priority over the other, then it will win or push it the other away. So.
Far right over there.
Does NavMesh currently play well with the 2D? Is there anything in terms of best practices for working with 2D?
NamUs currently it's always protected from top down, which makes it a bit hard to use with 2D because, you know, but as we explained earlier about this case that you might be able to, if you're able to rotate kind of how the NamUs is being built, I think then at that time we're going to look into making it play better with 2D because I think that then the kind of distance there to make it support 2D is just a...
It's definitely on the map.
Yeah.
So like we want to be able to rotate the NavMesh with any arbitrary transform eventually. And one of the big reasons for that is also 2D.
Yeah.
But then 2D, is it top down or is it that?
But that's something also...
We need to rotate.
Yeah, something also we would like to learn more about, like how do you build your 2D games? Like in some cases you have like empty background. Like in 3D games it's easy because kind of physics-based, you stand on ground. On 2D games could be that the background is totally, you know, invisible, but the NamMesh actually should be there. So I think there are a couple of like workflow things we need to figure out going 2D, and please contact us if you have a use for it. So we want to understand the use cases. Yeah.
You're talking about that you want to be able to project the NavMesh from another side, but would it be possible that scripters are able to define a different kind of projection? For example, my game is working on spherical planets, so it would be awesome to be able to generate enough mesh on a planet like a Mirror Galaxy, for example, or something.
Yeah, I think that's something that a lot of people also ask me when I was working when I'm working on Recast as well. So the way I will quickly explain a bit about how the project works. So the first thing that happens there is that we're going to voxelize the whole scene. And we're going to take like sort of like the one dimension of the voxelization. In a way, the voxelization should be sort of on sphere then, and it gets really nasty really quickly. So it kind of like what's going to be your projection is going to be the, you know, like I can't remember the names, but you know the one which has problems at the poles, or can we somehow project like a cube? But I think there might be a way to like make it like a cube and then connect the cube together. So I don't know. We need to try when we get there. But the sphere is something that comes up quite often. Maybe there's other way we can solve that. But automatically creating NamMesh for that kind of thing, not so easy with this method we are using. Like I know there's other ways of subdividing triangles and whatnot, depending on the game. But it kind of goes on the fringes anyway.
I mean, one possibility would be that the author creates basically enough mesh in another in 3D Max, for example, and then you use that to find the holes in that mesh, basically. So I give you the how basically, and you figure out where to punch the holes in.
So we do have a lot of like, you know, to make the code fast, we have a lot of assumptions that some things are inherently 2D. So when you have like curving word like this, it's not anymore. Like there's something like 2D topologies being used and stuff like that. So it doesn't translate very quickly. So you actually, like, just creating the mesh is kind of easy, but then the rest of the system needs to also support that. And we don't currently have any plans to do that. Yeah. Left there.
Yes. So in the demonstration that you had earlier, I saw that the nav mesh was projected at the top of the cubes. But I'm curious, like, what kind of assumptions are you making to projected at the top as opposed to, say, the bottom.
Should I go back to the slide and see if I can understand it better? So was it the example here and the begging, or?
Right, so when you baked it, you're actually projecting it at the top of your boxes there.
Mm-hmm.
What assumption are you making to determine that you need to put it at the top as
Okay.
opposed to the bottom?
So once the voxelization has been done, what we check at every voxel which is sort of on the up-facing surfaces, we will check if the agent capsule can fit in there. And all those voxels will become walkable. And then we'll do one more pass on that, basically to figure out the actual polygons. Like we'll turn the voxels into polygons again. But the test is that can I stand on this thing, not colliding with anything? That's sort of like the rationale of it.
You basically paint the top of the thing. So yeah.
And also
it has an inherent on the top of things built in.
And also there's a slope setting. Like if it's really steep polygon, we will just not use them during the like basically it will be discarded as a standable point if it's too steep.
Yeah, would you let us submit our own voxel data into the same?
Come again?
Would you let us actually use our own voxel data? Could you take our voxel data and bake that?
In theory, we could. Yeah, I'm sure how the API would look. That's always been the problem I had with the recast as well. Like how do you allow the people to kind of shove in their voxel data? Because in some cases, for example, kind of Minecrafty games, it might still be easier just have all the triangles and make the certain things match up. Because the one voxel actually represents a big chunk, like compared to the agent size. The way that the voxel size, which usually you can actually see it in advanced settings here. We usually have like 6 voxels per agent diameter, 6 to 8. It depends kind of on the use case. But then, like if you take that and apply it to your game, it could be that it's like 20 voxels, 20 recast voxels per one of your voxels, and then you kind of lose that mapping there really quickly.
Kind of related to that last question, but one of the things that happens in the moment with recast is it will generate nav mesh inside of objects.
Mm-hmm.
Would it be possible, possibly, for us to voxelize things as filled volumes rather than just as polygons too?
Yeah.
To eliminate some of that stuff, because it does make it harder in some cases when you're trying to sample positions or things like that to get to that mesh that you shouldn't be.
Would a seed point help in that case?
It might do, yeah.
Yeah, and I think like one cool thing about using the physics colliders as input geometry is that they're always guaranteed to be filled. So I think that could be another option.
In theory, you should be able to do with any closed mesh.
Yeah, any closed mesh. Yeah, that's right. Do the ray stabbing kind of thing. Yeah, right.
Is there a way to modify like weights at runtime? So if I got a pile of bodies somewhere and I don't want the guy to tap through that area?
Yeah. Currently, I don't think there is. In a way, you could make a hole in there, kind of make the same effect. Also, one thing that has come up is basically allow the carving to not create a hole, but also just mark an area. So we have to see if we eventually get there. But that's a good one. And also, I've seen in recast world people using sort of like debating with the density of the characters, making more costly those areas. But I think that comes with the more kind of granular runtime API. If you're going to expose the polygons of the animation and stuff like that, I think then it should be possible to change some of these settings as well.
You have the layer types, and I saw the cost in there, so you could have grass V2 versus table V1. Mm-hmm. Are those set only for the baking, or is that something where you could change the layer type of a section of the nav mesh at runtime? You could make an area more costly to go through.
You can't change the area type, but you can change the weight, and you can change the weight on a global scale or per agent.
And also, I think you can change an off-mesh link, but we don't currently support like telling individual polygons that this is a different weight now. But
you can change the area type of an off-mesh link though, but that's special. You can't change the polys.
Yeah.
Can you set individual NavMesh agents to ignore an obstacle or an off-mesh link? Say in the case where if you have like a locked door somewhere and you have one agent which knows the door is locked, but another does not.
Yeah, I think that the navigation representation we have is really bad for kind of local knowledge, like individual agents having a knowledge. The specific case that you just asked, we've been thinking ways of, could we have a callback in the off-mesh link saying that if it's available or not? It will be a really big it will actually affect pathfinding quite a bit because you need to do round trip to C#. We are looking into that kind of issues, and please contact us and let your kind of use case being known, because I think those are the things we are looking for in the case when we start working on the API, making it more gradual. Because I think like just trying to make it in a vacuum, it's not going to be a good thing. I think we need lots and lots of use cases and try to see the common patterns and try to build it from there. But that's a really good use case, I think. Also a really hard one because of unshared knowledge and how to do the callbacks efficiently, that sort of thing.
If you don't have too many doors, you can do it with the array types and switch out. But I guess you don't need that many doors to actually run out of area types, and then you have the problem. We need to solve this on a general case.
Yep.
Just quickly going back to the spherical planet.
Mm-hmm.
You said a comment that you will be exposing the polygon suit in the API so I can access it. Would it be possible that I create engine scripts to create the polygon suit and then just use detour on that? So that I can create the projection for me that works for my game, and then just use the navigation.
I think it goes back to my earlier comment that since the rest of the system assumes a certain kind of data, we want to keep that data sacred. So I've seen times and times again when you allow designers to create their own navigation data, there's always this one sliver polygon somewhere, and you spend weeks trying to find it. So I think I might go overboard trying to be sort of like making sure that the navigation data is kosher. But like in a way, this is like I've seen people spending months on trying to find those bugs. So that's the reason like we have automated process, so we know that we can trust the data. But I've heard the same thing that you said earlier as well.
That's on me then, right? If I create wrong data, that's my fault, and then I pay the price for it.
Yeah, and it's a bug I need to hunt myself for a month. So like these things, like they do come back to us, and we need to also figure out. But I hear your pain. I've heard the same arguments before. I'm still standing behind my own argument that the good data is better than some random data, even though it comes from you and it's really, really your problem. But I'm trying to save your time as well. But I think that if you want to talk about the issue about the spherical world, let's talk about it later. I have some ideas that might help you to solve it. Thank you.